One. So in the last lesson, we were talking about exponents, and I want to take it a little bit further today for the first. Let me actually just get rid of this bit here. I'm going to move into a slightly different area. Let's do it like this. I want to talk about what it means if we take a number and raise it to a fractional power like this. Does anybody know what the answer of 4 to the power of a half is? Now, in the previous lessons, we've been talking about powers where there have been whole numbers. But now I want to just go a little bit sideways and go, look, powers can also be fractions. Does anybody know what 4 to the power of a half is? You can pop your answer in the chat, or you can raise your hand and I'll unmute you. Let's go to Boipelo. Boipelo, what do you think the answer is?
So I think the answer is 2.
It's 2. I completely agree with you. How did you get the answer, Boipelo?
It's, I can't really explain it, but yeah, I just know my exponential laws.
Okay. Did you say to yourself 4 to the power of a half is the same as the square root of 4? Did you maybe do that? Some students might have learned about that equivalence.
Yes, sir.
Okay. So that's one way of doing it, is to know that the power of a half is the same as the square root of a number. So that's one way. There's also another way, and I'm wondering if anybody else can suggest to me how else we might be able to find the square, well, 4 to the power of a half. So I see Angela. Who else has an idea? Using the laws. Let's go to Ntando. Ntando, how else do you think we could solve this question of 4 to the power of a half?
So I think we would find the LCM of 2. I mean of 4, which is 2, and then it would be 2 to the power of 2 multiplied by the half, which is an exponential law.
Ntando, you've nailed it. You've nailed it. That's absolutely correct. Thank you so much. So Ntando is suggesting, Ntando's method is just take the number, which is 4, and break it into 2 squared. Now, 2 squared is just a number to a power. And now we have an exponential law that says if 2 powers are next to each other, we can multiply them. Okay, so what do we get then? So if you've got 2 and then you've got 2 times a half, well, 2 times a half is just going to be, you can imagine canceling these out, 2 to the 1 or 2. So there's actually 2 ways to do this question. The one is to convert from fractional power form to root form, which I haven't spoken a lot about, but some of you know. The other way to do it was to convert the 4 into 2 squared and use the power law. Give me a thumbs up in the chat if you understand the thinking behind that. Give me a thumbs down if you feel a bit lost. Sakile, at this point, we're not allowed to use our calculators. Sorry, I should have said that. This is, you're working completely without your calculators. Okay. So, awesome, awesome. Ethan, got it. Bonga, got it. Okay, so let's extend this idea. This idea today, we're playing with powers that are fractions, and we're trying to understand what they mean. So let me go to this thing over here. And let's focus on 8 to the power of a third. What do you think the answer is to this question, 8 to the power of a third? And what are the ways we could do this? And I want you to put the answer in the chat, and then those who are willing to share their thinking, pop your hand up. Atabonga, let's unmute you. What do you think the answer is, and how would you get it?
Sir, I think it's 2 because if you take the 8 and then you divide it by the 3, obviously you're gonna get 2. I don't know if it makes sense, but that's how I would do it in my
Okay,
opinion.
you're not going to divide, but you're very close. You're going to write it as 2 to the power of 3, aren't you? We say we break
Yes,
it,
sir.
we
Sorry.
break the 8 down into its prime factors. That's the fancy way of saying it. Okay, now talk me through the rest.
I actually didn't do it that way, sir. I did it as an
Okay.
what do you call this?
Root, like
For
a root.
example, yeah, I did it as a root equation. So I took the 8 and then put it where there was a 4, and then I put the third there, so it was like 8. Yeah, like that.
Perfect. Okay, so what you did was you recognized that the power exponent can be converted to root form. And we haven't really spoken too much about this, but it's true, and we'll write down the law now. But what this means is, what is the cube root of 8? And the cube root of 8 is 2, because 2 times 2 times 2 is 8. So you did it in a very similar way. The other way of doing this is to break down the powers and then into powers or prime factors, and then multiply the powers. And that would just be to say, well, what is 3 times the third? And that's just going to be 2 to the 1, which is 2. So the same answer is going to be 2 in both methods. Okay, so again, just give me a thumbs up in the chat if you understand this process, a thumbs down. Just want to get a good sense. I know I'm asking a lot, but this is a bit weird at first. And so, okay. Fantastic. Okay. Well, then what I want you to do is I want you to work out for me what is, not even that one. Let's not do that one. Let's do this. What is 27 to the power of a third? What is 27 to the power of a third? What's that going to be equal to? I see Angela's put something in there. Eunice has put something in there. Angela, would you be willing to share your thinking with us? Would you willing to share how you got to what you got? You just pop your hand up if you are willing. Otherwise, anyone else is willing to share what they did? Let's unmute Retabile if we can. Jordan, if you can see Retabile. Oh, wait, sorry, Retabile is in the waiting room. Let's Sia. I'll unmute Sia there. Hi, Sia. What do you think?
Afternoon, everyone in Hausa. So what I did was I said I broke down 27 to 3 to the power of 3.
Okay.
And then I put it in brackets, and then I still put the 1 over 3 over the brackets. And then I did a cancellation with the 3 and the 3's, and then it equal to 3 over 1, which is 3.
Yes, I completely agree with you. So the answer is 3. The other method that some people might have used is they may have converted 27 to the power of a third to be root form. So what's the cube root of 27? And the cube root of 27, we all know, is just, well, maybe we do or don't, is 3. 3 times 3 is 9. 9 times 3 is 27. Okay. Now, you guys have done really well so far. And what I want to point out is there is this law that we need to know about that says that if you have some number, so we're going to say, or a is a variable, and we say it's to the power of 1 over n, this is the same as the nth root of whatever that number is. Now that looks pretty scary, so let me show it to you in another form. If I said to you, what is 4 to the power of a half, we know that that is the same as the square root of 4. So can you see that connection between basically whatever this number is here, it's the same number over here. And so this is a law that is going to come up a bit today as we do this. And then there's another variation of this, which I'm going to write down, which is what happens if I have, let's say, actually, let me move below for this. Let me move. Actually, you know what? Let's start with this, and I'll do the other law later in the lesson. Okay, so what we've looked at so far is if we have fractions as powers, that's not a problem. We treat them a lot like we do normal numbers. And every now and again, we have to either break down the bases into their prime factors or change them into the root form. That's basically what we've done so far. Let's go to a question like this. Here's your chance to play along at home. If I say to you, what is 16 to the power of 3/2? I want you to think about that. And in the chat, I want you to put either A, B, C, or D. So what is 16 to the power of 3/2? Now, it's a bit weird, hey? Like, how do you raise something to a fractional power? We really have to get comfortable with this idea. What tools do you have? Okay, so I get some water while you guys are busy with that. So I see a couple of answers coming through in the chat. I like what I'm seeing. So I haven't worked the answer out. So what I was thinking is I could write 16 as 4 squared. And then what I could do is I could multiply those two powers and I'd get 2 times 3/2. And these 2's are going to cancel. So I get 4 to the 3. And I know that 4 to the 3 is 4 times 4 times 4, which is 64. And so the correct answer is B. B for banana. Yes, Sia, what is your question?
So I did it quite differently. So I
Okay,
said,
tell me.
I said 2 to the power of 4. And
Okay.
then in a bracket, and then I said to the power of 3/2.
No problem at all. And then you get 12/2, like that.
Yes, sir.
And then you got 2 to the 6.
Yes, sir.
And then you got 64.
Yes, sir.
Winning at life. Awesome. Not a problem. That is equally correct. Well done. Okay. Since you guys are smashing this, let's do another one. I'll upgrade it a little bit. I'll make it a little bit trickier. I'll leave the answer. And while you're doing that, everyone, if you have a question, you can pop your hand up. Now's a great time to chat while everyone is thinking about this problem. So this is 1/16 to the power of -1/2. Amtabonga, do you have a question? Let me unmute you.
I'm sorry, sir. By the previous question, I didn't quite understand how you did it and your method.
Okay, let me keep both questions in focus so you all can see. So Amtabonga, did you, what I basically did was think about 16, right? To the power of 3/2. Are you happy that 16 can be broken down?
Yes, sir.
Are you happy that 4 squared is a reasonable, 4 squared is the same as 16?
Yes, sir.
Okay, so we're together up to that point. Then the next step
Yes.
is what we call law 3. And all I'm doing is I'm multiplying the power inside the bracket by the power outside. So, and that's a law of exponents. And if you want to think of the 2 as 2 over 1, that could be very helpful because 2 over 1 is 2. Are you with me up to there?
No, sir. I
No.
lost you.
Yeah.
No.
Okay. So if you think of the 4 squared that's in the bracket, here is the 4 squared that was in the bracket.
Yes, sir.
And then here is the 3 over 2 that was outside the bracket. And what
Yes,
I'm
sir.
doing is I'm multiplying them together. And if I multiply 2 by 3 over 2, it's like saying 2 times 1.5. And so you get 4 to
Okay.
the power of 3.
Yes, sir. I understand now.
Perfect. Awesome. And then you get 64.
Thank
Okay,
you,
so
sir.
pleasure. So if you look at the second one, I see the answers that are coming through in the chat. Now, again, a lot of people seem to be going for B. Now, again, I don't know what the answer is yet, but let me try. Now, I'm not going to, 1 over 16, you know what I'm going to do is I'm going to write that as 1 over 4 squared. And so this is the same problem. And now I'm going to move the 4 squared up. And when I move the 4 squared to the top, I get 4 to the power of minus 2. There's still a 1 down at the bottom, but the 1 doesn't do anything. And that's the power of minus a half. Then the law of exponents says that if there's powers inside and outside, I can multiply them. So 4 to the minus 2 times a minus a half. A negative times a negative is a positive. So that's good news for me. So I basically just have then 2 times a half. And I'm pretty sure 2 times a half is just 1. And so we get 4 to 1. Or if you want to see it in terms of cancelling, 2 over 1 times a half, these 2's cancel and you get left. So I approve. I think the answer is B. Are there any questions in the class? Anybody who wants to clarify? Angela, yeah, let's go to you.
Hi, sir.
Hey.
I just wanted to ask, isn't it that when you move a number from the bottom to go to the top,
Yes,
the exponent doesn't it change the sign?
it does. Exactly. You're completely right. So can you see the 4 squared that is down at the bottom here now?
Yes, sir.
Now look how it goes up. It goes from the denominator to the numerator. It's all of a sudden above the line. Can you see how
Yes.
it changed to -2?
Yes, sir. I'm talking about the one outside the bracket, the negative half.
Oh, okay. Now the negative half is actually not moving up or down. It's actually being multiplied. So this is the law that like says, if I've got 2 to the 3 to the power of 4, I get 2 to the 3 times 4 or 2 to the 12. So these powers are being multiplied.
Oh, okay, sir.
Cool. Good question though. I like it. You helped a lot of students with that question because I can see a lot of people. Okay, well, I mean, this is definitely pushing you, but I definitely get the sense it's helping. And again, if I am going too fast, please do raise your hand and let me know if you want to ask more questions. I suspect there are more questions. So let me slow down and go back, and then for those who are feeling fantastic on this question, you can have a go at the next one, but I suspect I need to clarify a couple of things. So let's go to Angela.
So I already asked the question.
Oh, sorry. Okay, so you can put your hand down. Sorry, Angela.
I'm sorry.
Taboka, what's your question?
Sir, what I wanted to ask was, why couldn't you just put the negative in front of the 4 instead of saying it's 4 to the power of -2?
You could. So there's actually another way. There's another way. Did you get the same answer?
I didn't do it like that, sir, because I was busy with the question above.
Okay. the other ways to do this that would have got the same answer. So I think that what you're saying is fine if I'm understanding you correctly, but let's just check in the next question to see how it goes, because the next one I think you're going to have to apply directly. Okay.
Okay, so
Mr. S, somebody is asking if you could zoom in a bit, please.
Okay. I'll zoom. Oh, sorry, that's too much. Sorry, a bit hard to sometimes control the zoom. Okay, so this is the last question we're going to do before our break. And so we're going to slow right down so that people who have questions can ask. I want you to figure out what is 8/27 to the power of -2/3. Now, there's no calculators allowed in these questions. So Bonga, no calculators, I'm afraid. But you lose the laws that you've learned about. And then I want you to try, and there's not just one way to do this, there's multiple ways to do this. And so that's not a problem. You can share your ways, but I want to see if we can, and I don't even mind if you get it wrong or right. I just want you to give it a proper go here and think through, and then you can share your thinking with me. What makes this question harder? This one is a bit harder. I'd love for someone to put in the chat what makes it harder, or if you're willing to unmute yourself. What makes this question more difficult? It feels more difficult to me. Maybe I'm just being silly, but what makes it harder for you? There's no equal sign. Yeah. So that's not immediately obvious. Like, how do I simplify this? What does this equal? And I'm not allowed to use my calculator. That's something I must, in this section, you'll see the exam questions always say, without the use of your calculator. Lisa. Oh, wait, that's right. That's the waiting room, not the. Does anybody want to tell me why they think this is harder? So Mtabonga, yes, it's the 8 on top. It's the fact that we have a fraction inside and we have a fraction outside. And that makes it feel a bit cluttered. Yeah, I agree. Do you notice anything about the 8 and the 27 though? What's in common to both of them? Or, I mean, not in common, but yeah. I'll give you a little hint. Ntando, let's go to you rather. What do you think?
So on the exponential forms, they share 3. So 8 is 2 to the power of 3, and then 27 would be 3 to the power of 3.
That is absolutely true. Now, that is such an important part. Now, can you give me the next part? So you're absolutely correct. What you've spotted is that they both are raised to the power of 3. Is there a way I can deal with these 3s effectively? What do you think? Who knows? How do I get these 3s to play ball with me? Is there a law that deals with this? If the powers are the same, it turns out that you can write it like this. You can write 2/3 to the power of 3 like that. So just think about that. Now I've left out the other thing, which I'm still I haven't, got rid of it yet. There's still another power, and I could draw in another bracket if I really wanted to make it extra exciting. Although that maybe is a bit more confusing than it needs to be. Let me take that away for a second. It's a bit much. But do you notice that 2 to the power of 3 over 3 to the power of 3 could be written like this? And then this can be raised to, still needs to be raised to the power of that. So give me a thumbs up if you understand how I did this part over here. So it's like the 3 has been moved outside, and then I know these 2 need to be multiplied. Give me a thumbs up if you get that. It's a bit tricky. So all I'm doing, it's like saying, well, if I move this outside, I'm moving it up to here. That is allowed to be done because of law number 3 as well. So if you had this, if you had something like that, you could rewrite that as 2 to the power of 3 over 3 to the power of 3. So it's sort of like you're just bringing the 3 inside. Now, what's happening here is that 3 is being moved outside because it makes life easier for me. Okay, so a lot of people I've lost this. So that's not, we'll go through it a bit more slowly. Think about this. If I said to you, what is 2/3 to the power of 3? I can rewrite that as 2⁵ over 3⁵, because there's a 1 and a 1 here. So just tell me in the chat, give me a thumbs up if you understand that. Give me a thumbs up if you understand that part, just that part, not the question. Okay. Now think about this one over here. In this question, we first rewrote 8/27 as 2⁵ divided by 3⁵. So let's just, and we'll leave this -2/3 just hanging outside. Now, what's going to happen is I'm going to move this 3 outside. So I've got 2/3 to the power of 3, but the -2/3 is still to the power of all of this stuff. So now what we're going to do for that last step is say 2/3, and we have to multiply these two together. Now this is a bit trickier, but can you see how we cancel these out? So we now get 2/3 to the power of -2. Now, I know this is going to, don't stress if this is getting you a little bit, because if we want to bring this back inside, I'm going to get 2 to the power of -2 over 3 to the power of -2. Now, I want everyone to stop at that point and look at what I've done. I haven't got the answer yet, but I want you to try and choose the correct answer now using the working out I've done so far. What do you think the correct answer is from A, B, C, or D? And then I'll finish the answer in a second. So you've got 2 to the power of -2 over 3 to the power of -2. Now, this is a proper question here. So, like, I'm really pushing you to the limit here. Bom, let's go to you. What's your question?
Hi, sir.
Hey.
Sir, isn't the negative is for the whole fraction for -2/3?
So the -2/3 power is this thing. Let me get this. It's this thing sitting over here. And it is just hanging out until it gets called to action. Now, at this step over here, can you see how it's being multiplied by the 3 over here? And what I get left with is this. The problem is none of my answers have a -2 in. So what I've, or to power of negative, so I brought the -2 inside. And so my last step is going to actually be, or second last step, is to move the 3 above. And then when it goes below, we get that. So 3 squared over 2 squared. Because when I move it above the line, it changes its power. I'm basically finding a way to make it a positive power. So what's the final answer?
That's 9/4.
9/4. You are winning it live. 9/4. And the answer is D. Now, I think I can see a lot of you are probably still feeling unsure. Don't worry. This is, I'm maxing you out. We're going to have a quick little break. And then on the flip side, we will come back to questions like this. Okay, so what I want you to do is I want everyone to turn on their cameras. And I want you to stand up. And like this happy chap in the picture, I want you to stretch out. And I'm going to join you because, ladies and gents, we are only human and we can only push our brains so much at any one time. Okay, so Jordan, if you could help me by just shouting out to my enthusiastic students. I want you to start with me and just roll your shoulders. So just roll your shoulders nice and loose.
Turn on
There
your
we go.
cameras, everybody.
Come on, I want to see your happy faces. Oh, and just roll your shoulders. Get all the tension from the day. Oh, I can feel it melting away. And roll your shoulders forward. Then stretch your neck to the left. Stretch it to the right. Okay. And then let's do a tricep stretch. And hold it for a little bit. And do another tricep stretch on the other side. And then shake it out. Shake it out. And then we're going to do one little sneaky thing. So take your right hand and put it on your nose. And take your left hand and put it on your right ear.
People at the bakery already today.
Okay, now try and switch to the other side. Try and switch. So again, reminder, left hand, wait, so right hand on your nose, left hand on your ear, and now this hand needs to get to your nose, and this needs to get to the other side. And see if you can switch back and forth. And the more your brain gets it, the faster you can go. So the reason that's so tricky is it's a cross hemisphere thing with your brain. It's like it has to talk from one side to the other. So
Well done, everybody.
Yes, well done. I liked what I saw there. Do you feel a bit fresher? Give me a thumbs up if you feel a bit fresher in the chat. Do you feel a bit like your brain got a bit of a break? I call it the save as moment. When your brain goes, okay, I can download what I've done in the first part of the lesson. And then I feel like, okay, now I'm almost ready for part 2. Okay. So before we head to part 2, here's a bit of a mystery. Who doesn't like a good emoticon mystery? I want you to tell me what someone who's in love plus someone who is smiling is equal to. And here is your challenge question. So ask yourself, what is someone who is happy equal to in this question? So you can put your answer in the chat for what you think the happy face is. We can help each other along. Well, some of you are really, so a happy face, I think, is equal to 132. It's half of 264. And so then we have to ask ourselves, what is sunglasses face going to be worth? I'm just going to make it, what should I call it? A sunglass face. So I think a sunglass face, can I draw sunglasses? I don't know. I'll try. Well, if I add 132 to both sides, whatever the sunglass face is going to be 132 plus 68, which is going to be 200. So this is 200. And this was 132. And so what is being in love going to be? It's going to be 100. So what is my final answer going to be? So if being in love is 100 and being happy is 132, the final answer must be 232. Nicely done, Cynthia. Nicely done, Hearties. Oh, lots of you got it. Tabonga, well done. Sakile. So in maths, we call this a simultaneous equation, but it's also a fun way to kind of show you how maths can kind of apply to all sorts of contexts. Very nicely done, everyone. Okay, so we've had our brain break, and we are going to return to what we were speaking about already. So let us go to, in fact, let's do a slight adaptation of this one. Let's do this. If I say to you, this is now what we call an exponential equation. And the reason it's called an exponential equation is there's an exponent in the variable. So the variable is an exponent. So if you look at this, 8 to the power of 8 equals 2 to the power of n. Using what you know about exponents and their laws, I would like you to try and answer this question. And if you have a tip that maybe could help us, could you put that in the chat? So if 8 to the power of 8 equals 2 to the power of n, what is n going to be equal to? And if you feel very confused, you can raise your hand. If you can give us a hint in the chat, that would be awesome. Gondo, let's go to you. What's your question? Gondo, what's your question? Okay, maybe there was just a stray hand. Can anybody give me a tip as to how to do this? Like, what do you think is the most important step here? Fatego, let's go to you. What do you think?
Hello, mister.
Hello.
I don't understand the part when you're saying we must refer to laws.
Laws.
To exponential laws, yeah.
Okay. Fatego, would you agree with me that 8 can be broken down? Do you know what 8 can be written down? If I said to you, tell me what 8 is in terms of prime powers, do you know what that is?
No.
Okay, would you agree with me that 8 is the same as 2 times 2 times 2?
Yes, I will agree with that.
Yes. So would you agree with me that that's 2 to the power of 3 is the same as 8? And now in this question, we have 2 to the power of n.
Okay.
Now, what law do you think I'm going to use to help me in the next step? Any ideas? What do you think I'm going to do? So isn't there a law that says if there's a power next to a power, you can multiply them?
There is.
So how would you do that?
You will multiply the inner exponent with the outer one to get all results.
Perfect. And would you agree 3 times 8 is 24?
3 times 8. Yes.
Okay,
24.
now here's the final question. What is n going to be equal in this question? So you've got this equation and you have to solve for n. And I've worked with the equation. What do you think n is going to be? Or which option is it going to be? Is it going to be A, B, C, or D?
Option B.
Awesome. Because you can see that 2 to the power of 24 is 2 to the power of n. Therefore, these two must be the same. And this is how we solve exponential equations, ladies and gentlemen, or the simple ones. We make sure the bases are the same on both sides, and then we just compare the powers. But we have to make sure the bases are the same. If they're not the same, you can't say the powers are the same. Just give me a thumbs up if you understand that logic, that idea. The idea that in an exponential equation, what, like this, the bases have to be the same to say the powers are the same. Okay, awesome. How are we doing for time? Are we doing okay there? Let's avoid that one. Actually, no, it's not too bad. Actually, let's leave it for now. Okay. Let me finish with a couple of questions like this. And then we're going to call it a day. So what I want to do is I want to ask you to solve question 1, 2, and 3, and then we are finishing off for today. So what is, first of all, 8 to the power of a third? What is a quarter to the power of -2? And what is this whole thing to the power of a third? See if you can answer that, and then pop your answers in the chat if you can. And then we're going to call it a day for today. I think we've done a lot of working with fractions and powers and stuff like that. And then, yeah, Jordan, if I could just ask you to have that link on standby for the quiz, if it is available.
Yes.
Okay. So I can see in the chat, things are going well. So for question 1, no problems there. The answer is 2. Well done, DeCarlo, and well done all of those who got that right there. Let's see if you can do number 2. You'll see how the question says, solve the following expressions without a calculator. Oh, wait. Let's see if I correct there. -2, and that's, oh, I've told a lie. Let's have a look. I think I have. I definitely don't. Sorry, guys. I was being a bit silly there. Let me redo that. So that is 2 squared, not 4 squared. So that's 2 squared. And so now when I bring that above the line, I get that. And then I get negative times a negative, I get +4, and I get 16. Nicely done. Okay, so it's just question 3 to go. And there's a couple of ways we can do question 3. Oh, my pen is being a bit funny. So one of the things that I did was I broke down the 8 to 2 cubed. And then what I could do is I applied the power outside to the powers inside. So you'll notice that third gets applied to all of them. And so all I need to ask myself now is a 3 times a third. That's just going to be 2 to the 1. 6 times a third is going to be 6 over 3. Although we can simplify that. And then 12 times a third is just going to be 12 over 3. And if we simplify that further, we get 2a squared b to the 4.